All right, so that's a few days ago. Let me go to oh, and I'll get my little picture of myself up here. So if anybody's watching the recording, they'll see me. We've got two pictures here. Some people standing looking at a lava flow, and hopefully nobody's standing looking at this big. This is called a pyroclastic flow, or a pyroclastic eruption, or you could just think of it as a felsic eruption. So that's the really explosive kind. If you're miles away from that volcano on the right, you could die. And then you can see these people up in the top. They're just a few meters away, and they're okay. But if you get a few inches away, that lava is hot enough it could burn you, even if you don't touch it. So the question is, what type of plate boundaries might each of these eruptions have taken place? So let me see if I can do some complicated stuff with, oh, dang. Oh, there we go. With Windows here. I'm going to move this over here and search through some pictures that I have from the notes. Let's do. Oh, let's go to this kind of thing. So, looking at this is ocean continent convergent plate boundary. Do you think this volcano could look like either of those pictures? Yes or no? Nobody's going to answer. I'll just give you time to think, and then I'm going to tell you the answer. Well, this, you could have either of those pictures. So this dark stuff that's going on here and melting, that's what we see in the picture where the people are standing there. So sometimes this volcano is going to erupt like that. So it could be like the top left one. But then this light colored stuff, that seafloor sediment, that's the felsic stuff that doesn't really ever flow. It just builds up pressure and then explodes into ash. That's what we see on the right. So this kind of volcano could be either one of those eruptions. And now, if I go down to this picture, this is exactly the same as this, except for one thing. Everything is the same in here as it is in there. We've got all the same features. The only difference is here we have an ocean plate going under a continental plate. Like this is like South America, and this is like the Pacific Ocean, and this is like the Andes Mountains with all the llamas and the alpacas running around on it. But this is like the Pacific Ocean and the Japan Sea and the Pacific Ocean diving under and making Japan. But this could actually produce both of those kinds of eruptions in the picture too, because it's got sediment that's melting and it's also got ocean crust, so you've got both kinds of lava. And go through some other ones. This one. Hey, I'm going to kick out the dogs. Dogs are getting rowdy. Go! 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 Get! So could this produce the kind of eruptions in the picture, or any of them? And the answer is yes, but only the one on the left. Only the one where the people are standing next to the magma, because this magma that's coming up is the dark stuff, and it can never erupt like that picture on the right. This we're going to get to today. Let me go over a couple more places. Sorry, I'm a bit of a mess here. This one down here, if we were going to have one of those eruptions, which one would it be? Well, we could have an eruption because the mantle stuff is coming up to the surface. And this is dark stuff. So we could only have the eruption like the one on the top left. We would never have a big explosive one here. There is mafic lava, no volcanoes, but it would look different because this is the bottom of the ocean. All right, enough of that. Let's see if there was another question. What's the difference between magma and lava? I think I already explained this to you. yesterday, but magma is when it's down here. Magma is under the ground. And as soon as the magma comes out of the ground, then it turns to lava. And it's not just the name. Magma has, in this case, it's got all these little bubbles of water that's turned to a gas in it. So it's got bubbles of steam in there. And then when it comes out, those bubbles get released, so the lava doesn't have bubbles in it anymore. All right. Now getting to the last big things. We've got some more plate boundary drawings to do. So I have made a copy of my sheet of paper that I've been working on, and I'm going to draw the last couple of plate boundaries. Hopefully, by this stage in the process, you're feeling like you understand this process. So, one of the plate. I think what I'm going to do is turn off my overhead lights, so I get rid of that GoPro shadow. Last time this seemed like it was better. It makes everything a little bluer and darker, maybe, but I think that's okay. Too bad I can't adjust the brightness on this. And maybe I can, but I just don't know how. So the next one we're going to do is, let's just jump to the most, I don't know, it's kind of an interesting place, but it's sort of a boring one to draw. The San Andreas Fault in California. And the way I've drawn it here, it kind of looks like we've got ocean crust over here and continental crust over there. And maybe that's true on part of it, but a lot of the fault runs right through the middle of the state, so there really should be continental crust on both sides. Before I draw it, I want to show you some pictures of the San Andreas Fault. There are a lot of good pictures of fences that run across the San Andreas Fault. Fence across San Andreas Fault. They're very similar. So here's one. You can see this fence. Here's part of it, and there's the rest of it, and the fault is right in the middle. So the fence used to be one straight line, but then because the earth on our side's moving to the left and the earth in front of us is moving to the right, the fence got broken. Here's another one. Not quite as extreme, but just a little fence running along a road that got bent. Here's another one. Here's a whole road. You can see the road is now crooked. The road was straight when it was first built. So there are a lot of examples of this. This is a transform boundary. So, get back to my camera and my me, and I'm going to write plate boundary. We could call it continent transform. Let's just call it transform boundary. Now, if you want to do this in a really simple way, you can. If you want to try to make a nice perspective drawing, you can do that. So first, I'll do a nice blocky perspective drawing. But if you don't want to draw it like this, just hold on for a second. So we have basically a couple of blocks of crust. I'll do a simpler drawing after this. So we've been doing cross sections. That's not really a cross section. It's a perspective drawing. Now, if you'd rather just do this, that would be fine. You can just draw it like that. And that's really all there is to it. So we just can't draw what the currents look like in the mantle underneath this. We'll just have to stick with that. I do want to show you that, well, when I say we can't draw the currents in the mantle, that's sort of fudging, but I'm never going to expect you to. Transform boundaries form in a couple of different ways that I know of. And you don't have to draw this either. This is just to explain. you can have a transform boundary on a jagged convergent plate boundary. So if you have a couple of plates like this that are coming together, this would be a convergent plate boundary, but it's jagged. Anybody see the hidden transform boundaries in there? There are two of them. Just speak out if you see the hidden transform boundaries. Anybody? If you see them, just say, I see them.
I see them.
All right, good. So hopefully this is what you see. There's one here and there's one here. Because if this whole plate, right, if this plate is moving down and this other plate's moving up, then right along here, this is moving down and that's moving up. So there we've got a transform boundary. And right here, this is moving down and this is moving up. So right there we've got another transform boundary. So transform boundaries really happen in conjunction with convergent boundaries, or you can have the same kind of thing where we have a divergent boundary that's jagged. If we have something like this, where this is spreading apart, along here, this is divergent, and along here, that's divergent, and there it's divergent, but right here, this would be transform, and same thing right there. Transform boundary, let's make a little note. This happens, the best example of this is the San Andreas Fault in California. That's the most well-known transform boundary, at least as far as I know. The nice thing about it is when we check all that apply, there's not going to be much to check. So, are there steep composite cone volcanoes? There are no volcanoes, so we can skip all the ones with volcanoes. Ocean trench? No. Relatively violent eruptions of lava? Well, if you look at this, is there any way lava can come up right there? No. Now, in this picture, lava could come up here, but that's not really the transform boundary. That's a divergent boundary. So no. Relatively gentle eruptions of lava? No. Shallow earthquakes? Always. And that's the big thing here. There are a lot of earthquakes along here. If this edge is bumpy, the edge of this is bumpy and the edge of this is bumpy, these two things are going to catch together, and every once in a while they're going to go. They don't just smoothly move over time. They kind of go, like. They build up a lot of tension and then they slip. So we've got shallow earthquakes. Deep earthquakes, we need something diving. See anything diving? No. Subduction zone means something dives. Not one of those. The mantle below this is relatively cool. We can't see anything about the mantle here. It's just not really, no. New ocean crust? No. Mantle is hot? No. Tall mountains? No. Rounded shield volcanoes? No. So the only thing you have to worry about with a transform boundary is shallow earthquakes. But that's not saying this is a place where you never have to think about plate tectonics. People who live on the San Andreas Fault, they think about earthquakes quite a bit, way more than people in other parts of the world. Even though they don't have all these other things, they have a lot of those. And those can be bad. Just because they're shallow doesn't mean they can't be powerful. In fact, because they're shallow, they're closer to the people. So that can make it worse. Last kind of thing. I guess I showed you pictures of the San Andreas Fault, but let me show you a few more from a map view. I think I've got them on my website. I feel like I should open this in Google Slides because it's easier to get from slide to slide and show you exactly what I wanted to show you. All right, so this is one of those pictures of a fence. This is a picture from above showing the San Andreas Fault running through California. And right along here, Santa Barbara, Los Angeles, San Diego, Monterey, all those places that you've probably heard of are to the west of the San Andreas Fault. And then these other places are either on it or to the east of it. Santa Rosa, Garber. You probably never heard of Garberville. I haven't. But anyway, in 50 million years, Santa Barbara and Los Angeles are going to move out here into the ocean. So this part of California is going to slide away from the continent along the boundary, and it's just going to go out into the Pacific Ocean, assuming it keeps moving like it's moving. And that's it. Realized I had some good hotspot pictures I didn't show you yesterday. But we can come back to that some other time. I don't want to take too much time today. So the last one, the one that I haven't, that we kind of skipped over in the beginning, is this one, the East African Rift Valley. So this little tip of Africa here is breaking off and moving to the east, and the rest of Africa, relative to that, is moving to the west. So in several tens of millions of years, we're going to have an ocean here. In 100 million years, that'll be a big ocean. But right now, it's just a crack that's starting to form between the two plates of continental crust. So this one is going to be continent. Oh, where's my little friend? There he is. Continent. Divergent. And there are a lot of different names for this. It happens in Africa, and you can call this the Rift Valley or the East African Highlands. I'm going to call it the Rift Valley. This is a famous place for people to go and find fossils of early human ancestors. Because these fossils were buried underground, but now as the continent's starting to break apart, you don't have to dig down for them. They're just revealed there on the sides of these cracks that are opening up. So, continent means, well, I want you to try to anticipate this, like always, because at some point you're going to have to do these all on your own. Think about what I'm going to draw. Continent, divergent. So I'm going to draw a couple of plates, and I'm going to make them kind of thick because continental plates are thick. I'm going to leave them light colored because continental crust is felsic. They're going to be moving away from one another, like that. Then I'm going to draw the mantle down below, and the mantle below should be dark. It's the mafic material. And I'm going to draw the currents in the mantle below. So if these two plates are moving apart, that means the currents that they're floating on are moving apart. And the only thing that can make diverging currents like that is a rising current in the middle. So I'm going to have something like this. And the currents at the bottom of the mantle always go the opposite of the currents at the top. So things can cycle. Somewhere out of this picture over here, this will eventually come down and then come back. It'll come down at a convergent boundary somewhere over there and then come back again. Now, way back when we were doing ocean divergent, I was saying that it's going to look like two canoes facing off like this. And this is going to kind of be the same. This is going to look different at different stages. Don't draw what I'm going to draw. But if you just had nothing but a continent, and then all of a sudden down below this started to heat up, that would cause a rising current that would heat this area, that would just push it up. But eventually this would crack. So that's what I'm going to draw here. Maybe you could draw it going up a little bit, or maybe, however you want to draw this is fine with me. But it's just kind of like that. And over time, it's going to transition into two canoes facing one another. But this crack is going to form as this starts to move apart. And up in that crack, we're going to have some of this mafic magma coming up. And it's going to come up here, and it's going to harden. And for now, I'm just going to do that. And I'll make a note that this is new ocean crust. And it's ocean crust even if there's no water filling in over it yet. even if the crack hasn't connected with the ocean and filled in with water, this is ocean crust because it's made of the mantle material, and mantle material, when it hardens in a crusty layer, makes ocean crust. And that's kind of it. There's no volcano that's going to build up, because as more of this stuff comes in, this is going to keep splitting apart. And pretty soon, this is not going to be continent divergent. It's going to turn into ocean divergent. So in the notes that I gave you, I have a picture of this that's done a little bit better. So here's a more careful drawing. We've got continental crust, the new ocean crust forming, the stuff coming up in between, and I've actually shown a little bit of water moving in and starting to fill this up. So this is what this looks like now, but 50 million years in the future, it's going to look like this. So if I make a little dot right here, that little dot is going to be over there. And if I make a little square here, that little square is going to be moved over there. This pushing of the mantle will spread this apart. And as it spreads apart, new ocean crust is coming up and hardening in between. So now this is an ocean-ocean divergent boundary. So, and then the ocean will just get wider and wider and wider until for some reason this stops being hot, and maybe it'll turn cooler again, and then these will start to come back together. Those kinds of things happen over time. Nobody really knows why. So, let's do the checklist. Tall, steep composite cone volcanoes. Let me show you one. They look like this. There aren't any here. No. An ocean trench here? Well, this kind of seems like a trench. An ocean is forming in it, but that's not really what an ocean trench is. This is how an ocean trench forms. It forms at a subduction zone. So no. This would be, in Africa, this would be a valley. And I'll show you what it looks like. It's called the African Rift Valley. Relatively violent eruptions of lava. In order for that to happen, we need felsic, light-colored lava, and there isn't any. All there is this dark-colored lava. Relatively gentle eruptions, yes, because this is going to erupt. Shallow earthquakes, always. So you get some just anytime the crust moves, you can have shallow earthquakes, and because of this magma sort of belching its way out of here, like thick stuff boiling on a stove, that can shake the earth too. Deep earthquakes only happen places like this, subduction zones. So no. This is a subduction zone? No. One plate has to go under the other for that. The mantle below this area is relatively cool. Well, it's rising, so this is actually relatively hot. New ocean crust is being created here. Yes. Yeah, this is making new ocean crust. And that's going to become a big ocean. The mantle is relatively hot. Yes. Tall mountains, but no volcanoes. No, not really any volcanoes and no real tall mountains. Rounded shield volcanoes, no. And that's everything for a continent divergent boundary. Let me show you a few pictures of that. I think I probably have some in here. Maybe I don't. Maybe I just have pictures of where Africa's splitting. So here's the... Looks like it's not just one single crack. It's a few. And see how they have volcanoes along there? I just told you that there aren't volcanoes along here. Well, I guess... Oh, shoot. There are exceptions to everything. But if, for some reason, if you look at this from above, I think I was explaining this before. If you have a crack that's opening up, if I rip this paper and I started to pull it apart right here, and magma's coming out the center, it can't really pile up there because this is being separated. But right here and right here, where the movement apart is really not so much, stuff could start piling up there. So there may be some places, and clearly there are some places along this, where the separation is not fast enough, and this is piling up. On the other hand, these volcanoes that they listed, they might not actually be volcanoes, they may just be lava flows. So when they have those red triangles in the picture, Those red triangles might just be lava actively coming up from the ground. All right, so let's see this. What's this other one? This is just another picture showing how Africa is splitting apart. And I want to find, even though I don't have it on here, one good photograph of the African Rift Valley. There are a lot of different ones. There are a few that I really like. This is a good one. So this one shows continental crust over here, continental crust over there. This doesn't look like mafic stuff in the middle, but this is probably sediment that's washing in, that's eroding in from these two sides. Let me do African Rift Valley basalt. Basalt is the name for the type of rock that forms from this type of magma. I'm not really seeing much. Lava flow. Oh, here we go. So this is a good one. This is the picture I wanted. This, you can definitely see continental crust over on the right, and you can see continental crust on the left, and you can see where the magma is coming up here. And it does sort of look like this is piling up, and it is making a kind of a rounded shield volcano here. So maybe on the sheet that I just gave you, on this one, rounded shield volcanoes, if you wanted to select that, you could, because it does look like in some cases you get these rounded shield volcanoes. Over time, though, those volcanoes are they're just going to fall back into the ground, because this whole thing is going to keep splitting. So they can never really get very high. So remember, if you want to select that one on a test, you just need to tell me afterward. Mr. Stapleton, you showed us a picture. Sometimes you can get rounded shield volcanoes in there. All right, that's all the time I'm going to take.